The one concept that distinguishes geography from other fields is location, which is central to a GIS. Location is simply a position on the surface of the Earth. What is more, nearly everything can be assigned a geographic location. Once we know the location of something, we can put it on a map, for example with GIS. Generally, we tend to define and describe locations in nominal or absolute terms. In the case of the former, locations are simply defined and described by name. For example, city names such as Tokyo, New York, or London refer to nominal locations. Though we tend to associate the notion of location with particular points on the surface of the Earth, location can also refer to geographic features, such as the Rocky Mountains or larger areas, for example, Siberia. Contrasting nominal locations are absolute locations that use some type of reference system to define positions on the Earth's surface. For instance, defining a location on the surface of the Earth using latitude and longitude is an example of absolute location. Postal codes and street addresses are other examples of absolute location that usually follow some form of local logic. Though there is no global standard when it comes to street addresses, we can determine the geographic coordinates, for example latitude and longitude, of a particular street address, zip codes, place names, and other geographic data through a process called geocoding. There are several free online geocoders that return the latitude and longitude for various locations and addresses around the world. With the advent of global positioning systems, GPS, determining the location of nearly any object on the surface of the Earth is a relatively simple and straightforward exercise. GPS technology consists of a constellation of 24 satellites that are orbiting the Earth constantly, transmitting time signals. To determine a position, Earth-based GPS units, for example, handheld devices, car navigation systems, or mobile phones, receive the signals from at least 3 of these satellites and use this information to triangulate a location. All GPS units use the Geographic Coordinate System, GCS, to report location. Originally developed by the United States Department of Defense for military purposes, there are now a wide range of commercial and scientific uses of a GPS. In order to determine direction, a reference point or benchmark from which direction will be measured needs to be established. These benchmarks include egocentric direction and landmark direction. In geography and GIS, 3 more standard benchmarks are used to define the directions of true north, magnetic north, and grid north. True north is based on the point at which the axis of the Earth's rotation intersects the Earth's surface. In this respect, the North and South poles serve as the geographic benchmarks for determining direction. Magnetic north and south refers to the point on the surface of the Earth where the Earth's magnetic fields converge. This is also the point to which magnetic compasses point. Note that magnetic north falls somewhere in northern Canada and is not geographically coincident with true north or the North Pole. Grid north simply refers to the northward direction that the grid lines of the latitude and longitude on the map, called a gradual point to. Complementing the concepts of location and direction is distance. Distance refers to the degree or amount of separation between locations and can be measured in nominal or absolute terms with various units. We can describe the distances between locations nominally as large or small, or we can describe 2 or more locations as near or far apart. Absolute distance is measured or calculated using a standard metric. The formula for the distance between 2 points on a planar surface or a flat surface is as follows. Distance is equal to the square root of the change in the x direction squared plus the change in the y direction squared. Calculating the distance between 2 locations on the surface of the Earth, however, is a bit more involved because we are dealing with a 3-dimensional object. Moving from the 3-dimensional Earth to a 2-dimensional map on paper, computer screen, or mobile device is not a trivial matter and is discussed in greater detail later.
Where distance suggests a measurable quantity in terms of how far apart locations are situated, space is a more abstract concept that is more commonly described rather than measured. For example, space can be described as empty, public, or private. Within the scope of a GIS, we are interested in space, and in particular, we are interested in what fills this space and how and why things are distributed across the space. In this sense, space is a somewhat ambiguous and generic term that is used to denote the general geographic area of interest. One kind of space that is of particular relevance in a GIS is topological space. Simply put, topological space is concerned with the nature of relationships and the connectivity of locations within a given space. What is important within topological spaces are 1. How locations are or are not related or connected to each other, and 2. The rules that govern such geographic locations or relationships. Transportation maps, such as those for subways, provide some of the best illustrations of topological spaces. When using such maps, we are primarily concerned with how to get from one spot to another along a transportation network. Certain rules also govern how we travel along the network. For example, transferring lines is possible only at a few key stops. We can travel in only one direction on a particular line. Such maps may be of little use when traveling around a city or by car or foot, but they show the local transportation network and how locations are linked together in an effective and efficient manner. Transportation maps illustrate how we move through the environments we live, work, and play. This movement, and in particular destination-oriented travel, are generally referred to as navigation. How we navigate through space is a complex process that blends together our various motor skills, technology, mental maps, and awareness of locations, distances, direction, and the space we live. The acquisition of geographic knowledge is a lifelong endeavor. Though several factors influence the nature of such knowledge, we tend to rely on 3 following types of geographic knowledge when navigating through space. The first is landmark knowledge refers to our ability to locate and identify unique points, patterns, or features, for example, landmarks, in space. The second is route knowledge, which permits us to connect and travel between landmarks by moving through space. And the third is survey knowledge, which enables us to understand where landmarks are in relation to each other and to be able to take shortcuts.